Hello everyone, welcome to you in the series AI for .NET developers and tech leaders. In the last session, we established something very strong and very important. What ML.NET is not a deep learning training framework, and that is by its design. Yes, so, what ML.NET actually? ML.NET was built for feature-based machine learning, regression, classification, clustering, and forecasting on the structured data, right? Which we already experienced in our previous sessions. If you are new, then I recommend you please check the roadmap and start from the fundamental to regression, classification, clustering, then move to deep learning. And if you already have knowledge of machine learning, classic machine learning, then you are most welcome to continue with the session. So, as we're talking about what the limitation and what ML.NET built for, that is built for feature-based machine learning. But the modern age of AI right now or nowadays, computer vision, large language model, document intelligence, copilot, these all does not run on hands-on engineering feature. It run on deep learning models. And those models, that's their own representation, and the representation is what the representation from the raw data, because the deep learning model, you don't need to train them based on your feature engineering or based on your pipelining. It's although learned by itself from the data. It creates a pattern from the data, right? So what actually this video and what you will understand by this video at end of this video, here I'm not, and what I'm going to teach you or going to tell you in this session, in this video, I'm definitely not showing to you any heavy mathematics concepts, or I will not explaining you the neural networks inside it, how neural networks are works. Definitely not. Instead of deep down into how things build, we will going to show you deep learning ecosystem, how ecosystem of deep learning actually works, and how ML.NET fits into it, because this is very important for you to know the deep learning ecosystem which is best fit with the ML.NET. By end of this video, you will understand the fundamental concepts of deep learning, what are tensors, layers, neural networks, embeddings, CNN transformers, and LLMs really mean. Till now, you may use ChatGPT, you use Gemini, you use many LLMs, but do you know exactly what is mean by LLM? I will not give you any academically, but in terms of how they run inside real .NET application, that is my focus, and that's my mission, to train each and every .NET developers and make them AI ready in the future. Yeah. So let's continue and see what things available and how we can improve ourselves. Let me give you brief about our past session, just to connect the bridge in between what in past we discussed. As you know, classic machine learning or machine learning, and with ML.NET, what you have here, you can see it very clearly. What you have here, we have, can you see this? We have feature engineering that you did. You have ML algorithm, you choose the right algorithm based on your decision, and then you optimize it and you train it, and then the prediction will comes as an output. But in deep learning, it's different. In the deep learning, there is a data, and then the training itself with the neural networks. So there are multiple hidden layers in between. You input your data, you input your requirement, and then the processing will be turned into the many hidden layers. This is called neural network, and there is a backward propagation, forward propagation, and weights are involved there, and after that it just gives you the output, because the learned representation, the networks, the neural networks you can see here, learns from each by each self, yeah, learn by the representation, and ultimately at last you have the output. That output you do have. Let's dig it down. This is the very higher levels. I know you have confusion, or you have any question in your mind. Let's dig it down. What is exactly, yeah? So deep learning means what? In the deep learning means you are removing feature engineering. There is no feature engineering. You removed it because model will learn itself. So here you can see the neural networks comes in the picture. So the neural networks will learn by its own. Yeah. So we have data, and then many hidden layers inside it. To try the hidden layers of the neural networks, try to understand the pattern in our data, and then based on that they create the representation and produce the output or produce the prediction. In this, in the deep learning, some things are very important. At a higher level you need to understand, there is a one thing is CNN, convolutional neural networks. What you have image data, and then the image features extraction, feature engineering of image, and the layers, edges, shapes, objects, pixels. This is done by CNN. And here again, transformers, text feature engineering, this is also automated here. You don't need to do anything. This is already trained by libraries, and the models already trained. So transformers is available with us. What transformers, what exactly the transformers do? Embedding learns word and sentence meaning. I will show you going forward. I will also record several sessions on the topics, let's say transformer and what is the transfer learnings. I will show you, but you need to understand at a bigger level, at a higher level, what things actually inside the deep learning. And the LLM, everyone now, I would say it's wrong, everyone, most of us nowadays use LLM, large language model, knowledgeable model trained on huge data, trained with many things. It can regions, it can generate text, it can generate image, it can generate code, knowledge, logics. This is LLM, large language model. The large language model, many large language models available nowadays in the industry. Those models are GPT models. We have yeah, many others, Llama models. We do have Mistral models. We have many models available. We will walk through those things as well. So try to understand in the deep learning, this deep learning system, we have CNN, convolutional neural network, which is process your data in the several hidden layers, apply what inside it, they apply loss functions, they penalize it, they reward it, and then gives you the data. Internally huge calculations happen internal in the deep learning models. After LLM, we have AI agent, language models plus tools. So what AI agent? Let's say you have LLM, and then you want to, my LLM will process something and give me processed output. How it's processed? For example, you are a travel company and you build your agent, utilize LLM, pick or the search the holidays data, search from the holidays database whenever, or hotels packages, whenever customer search anything for holiday plan, the LLM should go into my database, and then the information which I already stored in the database in terms of documents, in terms of text, SQL, JSON, what all the combinations or the formats of information I stored in the DB, that will collect by LLM and then process it and provide the output. This is called tooling, agent with tooling. Now the question is, where ML.NET fit in it, guys? This is question in your mind also, right? ML.NET fit where it's fit. So we have deep learning model. Now the question is, ML.NET is enterprise runtime for your deep learning, deep intelligence. So you build your model, or the models already available. If you interested to building your deep learning models, you can use the libraries PyTorch, TensorFlows, Keras. You can build your model. Let's say you build your model in the Python and then export those model with ONNX, and ONNX runtime available in the ML.NET. Through this you can run your model in ML.NET. So that's the beauty. The machine learning models, deep learning models, you trained or you pull pre-trained model and run on your environment using ML.NET ONNX runtime. So here you can see ML.NET. What's it? ML.NET is here, ONNX model, ONNX runtime, ML.NET, and then your C# code. So you have your application. Let's say you have a web application and you want to run any or plan the deep learning model. So you can export this model with ONNX supportable, and most of the models supports ONNX, and then you can run it. So ML.NET is supporting you to run ONNX model, integrate with your apps. You can do it. Now try to understand that this is, guys, deep learning ecosystem. How deep learning works. It's not only to understand deep learning and training a deep learning model, but the most important concept is, and my mission is, to train .NET developers where you understand and where you build your understanding how you can utilize deep learning models which is already available, how you can build a project, how you can provide value to customers. That's the objective. Our objective is not to learning a maths or learning a statistics and dynamics. Yeah, we will utilize, we'll use those things which is already available in the industry and then integrate into our platform and then provide the solution to the industry, isn't it? Some core concepts I added here, so I will definitely not deep dive it, but it would be good for you to understand what are the terms in the deep learning. In the next session, definitely I will start walk through our further things in the deep learning which is supported by ML.NET, but try to understand some, I would say, alphabets, some fundamental alphabets of deep learning. In deep learning we have tensors. What are tensors? So tensors are multi-dimensional data arrays which is optimized with this GPU max, batch high bits. You have a high number of batches. Yeah, that's the tensors basically. It's not array, it's not matrix, it's a high dimensional data. Yeah, and we have layers. So as you've seen, I will also show you the playground of deep learning, but later on. So we have layers in the, this called neural network, just like human brain neurons. So the deep learning neural network also think based on the human brain. You input some information and then your brain start processing based on the data what you have. This is called learnings. What you already have, based on your learning, your brain start processing and then generate output. So that's exactly a schema of deep learning. You input information, neural network start processing, and based on the processing, based on the weight is a knowledge, because if you as a human, we think something, then how we think something based on the knowledge, because the child, a small child, cannot think as a adult. Yeah, it's based on the knowledge. So the knowledge you have, this means the weights, the knowledge you have, based on that knowledge you think, you process, and then you reach an outcome. Similar way deep learning models done this. So in the deep learning model we have CNN, convolutional neural network, RNN, recurrent neural network, and then dense layers. Weights available. So for each layer we have parameters. Those are learned during training, that store the knowledge. Millions, trillions, billions of tokens are available with us. Billions of weights are available. Weights are a main concept, main function of a deep learning models. Yeah. Activation functions introduce non-linearity into network, essential for learning. Your model will decide which activation function will use. Yeah. And there is ReLU, sigmoid, TANH, these highly used activation function. Loss function we do have. Loss function measures overall error. So your model will learn itself and then updates the weights during the training based on the errors. Embedding, learn vector representation of input data captured semantic. We will explain the embedding, vector DV. There are many concepts going forward, and those are very interesting, guys, for you if you're starting with a deep learning, and then we move as soon as we start moving with the Gen AI, and we will definitely dig it down in depth, and we try to figure it out how we can do this and how we can use those things. Main basic concept, I think everyone should understand, everyone should learn: model versus architectures. Architecture is design, model is trained weights, and training versus inference. Because in the classic machine learning, you are training your model, you have data, you are training this, but there is a one more term is inference. In the deep learning, you will not train deep learning model, you will use deep learning model, or you will run deep learning model. That's called inferencing. Inferencing we will use in ml.net. So here you can see we have let's say here you can see the information. This is the information what we have here. We have ONNX model, ONNX runtime. ONNX model is what? The model, you already pre-trained models already available, or you train your model, and then ONNX runtime, ML.NET, and your C# application. So easy, yeah. In this way, we can use deep learning models in our ML.NET. Now let's see what ML.NET commit by this, what Microsoft committing for deep learnings. Let's have a look up on this as well. Let's see what Microsoft committed for deep learning. So this is the page for ML.NET where Microsoft describing or announcing about the deep learning, what deep learning is. So this already I explained you can watch my previous videos. Deep learning versus machine learning, we talked in this session. What are neural network architecture? You put the input, then activation or the hidden layers are performed, and then it's input, weight, bias, means through weights and the penalties and rewards, the model learn and then provide the output. What types of architecture neural network is, this I tried to explain to you that the different types of architecture we do have. What can I use deep learning for? Where you can utilize the deep learning concept. The deep learning you can use for image classification, to detecting the object inside the image. Yeah, audio classifications, translations, text generation, text classification. These are the high level use of deep learning. Where deep learning exactly fit in machine learning ML.NET? That's important, guys. Let's see. Deep learning in ML.NET. Training a deep learning model from scratch requires setting several parameters, large amount of data, of labeling training data, vast amount of resources, hundreds of GPU hours. If you have a GPU, most welcome. You can train it. If you are interested, comment in this. I will also record sessions in a how to train deep learning model using Python. Uh, that's not viable with the ML.NET, but I can record a session for you how you can train deep learning model, your own deep learning model in a Python. I will record it. If you are interested, just write in a comment. ML.NET enables you to shortcut this. Shortcut means what? ONNX runtime, and then you export your model as an ONNX compatible, and then use the ONNX runtime in ML.NET and use that model in ML.NET. Yeah. Microsoft clearly explained, depending on the scenario, you can use local GPUs as well as Azure GPU compute resources to train and consume deep learning models. It's up to you. If you want, you can do this. There are libraries. How to train custom models. There are libraries. TorchShop, TensorFlow.net. You can utilize those. And some of the high level example, which going forward I will also explain. I will record practical session for those things using ML.NET, how we can use deep learning models. So first is image classification, where we will have many images. Let's say we have image for dog and cat, and we have thousands, 10,000 lakhs of images of cats and dogs, and as soon as I provide the dog image, the model will recognize. Yeah, this is image classification. Next is object detection. You have a video or you have an image and you want to detect the object. Let's say I'm a casual, and then I provide my image, my photographs to the model, and I've given a image where hundreds of people are standing or sitting, and I ask, hey, where is caution? So this image, this object detection will do that. Text classification, very important. Text classification is supported where you classify your text, where you want it to fine-tune the text. Let's say sentiment analysis, customer review, movie review, you wanted to that. There are several research papers available. I will I will provide you the link of research papers, and if you are interested, then you can see here Microsoft clearly given almost all kind of links, hyperlinks are available. You can try it out, and you can read. Definitely you need to read it. You need to invest your time. Yeah, because time is money, time is value, time is money. If you invest it, you will reward it. Sentence similarity and consume pre-trained model. So as we already understood what is pre and what are the features, TensorFlow we do have, ONNX we have here, ONNX we do have here in ML.NET. So this is at a complete ecosystem, guys, how we can utilize deep learning in ML.NET. You don't need your technology. You don't need to start learning Python to learn machine learning or artificial intelligence. You can stay in your domain. What are your expertise? You can stay on that and then build your knowledge in AI and machine learning. In the next session, I will record practical concepts, practical topic for image classification, text classification, and then slowly I will move to transfer learning, where we use the transformers, and then we start using Gen AI. Yeah, I think you everyone is waiting for a long time when I start Gen AI. So once deep learning concepts are reached at end level, I will start the Gen AI, where we talk in detail how you can use transformers, how you can use transfer learning, how you can create your own AI agent, what is AI agent, where you deploy ML ops. Yeah, so many interesting topics still awaited. So let's continue your practice. Thank you very much. See you in the next session.